Hi Trey, today we actually be continuing with calculating the amount of a substance in using the volume of gases. You should be referring to CAB page 78 and page 79 for this section of lecture. So by the end of this section, you should be able to perform calculations involving molar gas volume and the number of moles of a gas. So today I'm going to introduce to you another formula in which you can calculate the amount of substance using molar gas volume. So what is this molar gas volume? According to Avogadro's law, equal volumes of all gases under the same temperature and pressure will contain the same number of particles. What do I mean by that? Okay, generally, as long as if the balloons over here, they contain the same volume, would they contain the same number of gaseous particles? Take about 5 seconds to think about this question. Okay, the answer should be yes, they do. As long as we are referring to the same temperature and pressure, which means the same conditions, if they contain the same equal volume, they will contain the same number of particles. Okay, so now I'm going to introduce to you what is this molar gas volume. This special molar gas volume number is actually 24 dm cube. So it states that as long as it's 1 mole of any gas, it will occupy 24 dm cube, okay, at room temperature and pressure. Room temperature and pressure is the only conditions that you will learn in this syllabus. Okay, so pay attention that as long as the question mentioned room temperature and pressure, 1 mole of any gas will occupy 24 dm cube. Okay, any gas refers to hydrogen, oxygen, nitrogen, carbon dioxide, methane, and helium. Okay, so it doesn't matter what is the chemical formula of the gas. It doesn't matter about the molar mass of the gas. You just need to understand that as long as it is a gas, okay, at the same conditions, they will occupy the same volume. Okay, and this is the first time that you're looking at this unit called dm cube. Okay, so it is good to pay attention to know that actually 1 dm cube is equals to 1000 cm cube. So when you're performing the calculations, please pay attention to the units given, because depending on the question, sometimes you may use cm cube or sometimes you may use dm cube, and you need to use the correct 24 dm cube or 24,000 cm cube respectively. Okay, and what do I mean by room temperature and pressure? It means that it is 25 degrees Celsius and the pressure it is 1 atmosphere. Okay, so 24 dm cube is known as the molar gas, okay, of a molar volume of a gas at room temperature. Okay, so now let's move on. Okay, so therefore this means that 1 mole of oxygen will occupy a volume of 24 dm cube. 1 mole of hydrogen similarly will occupy a volume of 24 dm cube. 1 mole of carbon dioxide will also occupy a volume of 24 dm cube. 1 mole of methane will also occupy a volume of 24 dm cube. 1 mole of helium also occupy a volume of 24 dm cube. So as seen here, it doesn't matter what is the molar mass of the gas given, whether is it monoatomic, whether is it diatomic, it doesn't affect the molar volume. 2 moles of oxygen will then occupy a volume of 48 dm cube. And similarly, 3 moles of nitrogen will occupy a volume of 72 dm cube. Okay, so now the next question will be to ask yourself, do the balloons of the same mass have the same number of particles? So now assuming that each of this volume here have 0.18 grams, okay, this is oxygen, this is hydrogen, this is methane, this is nitrogen, this is helium, and this is carbon dioxide. You might want to think about the previous formula that you have just learned about using molar mass, and think about it whether do they contain the same number of particles. Okay, so the answer is no, they will not contain the same number of particles in this case, because if you were to use the molar mass volume, whereby amount of substance equals to mass divided by molar mass, you realize that each of these gases, they contain the different number of particles. Okay, so equal masses of gases do not have the same number of moles, and they do not occupy the same volume in this case. Okay, so now let's move on to how do we go about calculating the amount of gas using the molar volume. So take note on page 78, okay, the formula there in the triangle, they use the word mole, but I'd like you to change it to amount of gas. Okay, for our school, we are going to focus on using amount instead of using number of moles. For various substances, we are going to use amount. Okay, so amount of gas equals to volume of gas in dm cube divided by 24 dm cube. So you only use this molar volume of 24 dm cube if the question gives you the volume of the gas in dm cube. Okay, similarly, if the question gives you cm cube, you're going to use 24,000 cm cube in your calculation. Now let's take a look at example 1. How do we calculate the number of moles of carbon dioxide in 3 dm cube of gas at RTP? So right now, in order to calculate the amount of gas, carbon dioxide gas, okay, and you should have paid attention that it is in RTP, which is room temperature and pressure. So therefore, you should be using amount of gas equals to 3 divided by 24 dm cube in this case. Okay, we're going to use 24 dm cube because the question has given us 3 dm cube. Okay, in this case, the units are all in dm cube, and you should be able to get an answer of 0.125 moles. Take note and pay attention that all answers should be left in 3SF, and you should be able to write your own units. Okay. Now, what is the relationship between volume of gas, number of moles, and molar gas volume? So in this case, this is a repetitive of what this previous slide is about. Okay. So now in this case, if I were to calculate the volume of the gas over here, you need to use, okay, we don't use number of moles, we use amount of substance times 24 dm cube, or amount of substance times 24,000 cm cube. And do bear in mind that 24 dm cube or 24,000 cm cube is only used for room temperature and pressure conditions. Okay, so this is also what is given in your CAB. Please help to make the amendment that instead of using number of moles, we are going to use amount of gas in this case. Okay, so now let's take a look at example 2, which is not given in your question. Now, if I were to ask you to calculate the volume in cm cube of 0.75 moles of methane gas. Okay, so again, it's in RTP. What would you go about doing it? Okay, you should know that the volume equals to amount of substance, which is 0.75 moles, okay, times the molar volume. And in this case, should you be using 24,000 cm cube or should you be using 24 dm cube? Okay, I hope that you should know that we are going to use 24,000 cm cube because the question did mention that they want to answer in cm cube. Okay, so by calculating this, you should be able to get 18,000 cm cube. Okay, if you are comfortable, okay, so before I go off first, there are two ways to calculate the number of moles of a gas. Okay, so depending in order to calculate the number of moles of gas, which is the amount of substance, you can choose to use the mass formula if the question provides you with mass, or you can choose to use the volume formula if the question provides you with the volume. So take note and see which question, what is given in the question. Okay, so now let's take a look at question 5C on page 79. How do I calculate the amount of substance in carbon dioxide in 22 grams of carbon dioxide? So because the question has given you in mass, okay, 22 grams, okay, you might have to use the mass formula. So amount of substance equals to 22 grams divided by the molar mass of carbon dioxide. So referring to the formula, you should be able to derive that, okay, the molar mass, okay, in this case is 12 plus 16 plus 16. Okay, and then leave your answers in 3SF again and with units. Okay, if you are comfortable at this point onwards, you can go ahead and try example 5D on page 79 on your own, instead of me revealing and going through the answer. Okay, so let's take a look at 5D. Calculate the amount of substance in 4 grams of oxygen gas. Okay, do take note that oxygen gas, you should know the formula by now. Okay, if you have memorized covalent substances, okay, it should be O2. Okay, so if you like now, you can choose to pause first. Whereas you can choose to pause first and complete the question first before I go through the example. Okay, so amount of oxygen in moles. Okay, it is again mass divided by molar mass. Okay, the mass given is 4 gram divided by 16 plus 16 because oxygen has a formula of O2. Okay, then after that, leave your answers in 3SF. You should get 0.125 moles. Now I'll move on to question 5E. This is 5E. Okay, hold on first. Okay, sorry, I'm going to move on to question 5E, which is to calculate the amount of substance. Okay, but in this case, what do you notice about the what is the given value? Okay, it is 0.12 dm cube of carbon dioxide. So you should think about it whether I'm using the molar volume formula, or should I be using the molar mass formula. Okay, so try to recall. Sorry, this is the amount of carbon dioxide in moles. Okay, you should be using sorry for this amendment, please take note that this is CO2. Okay, volume divided by the molar volume, 0.12 divided by 24. Okay, in this case I'm using 24 because the unit over here is in dm cube. Okay, and then you get your answer and round it off to 3SF. Okay, please take note that okay, for now, if you're wondering whether we need to write the formula, you don't have to in exams, but because right now you're at the beginning stage, it is good to actually write down the volume to help yourself first. Okay, now we'll move on to question 5F, which is to calculate the amount of substance. Okay, and it's given that it is 200 cm cube of ammonia gas. Okay, so right now, if you like, you can actually choose to pause the video first and try the question first before I actually go through the example. Okay, so if you were to look carefully, we are given cm cube, so you will be using 24,000 cm cube in this case. Okay, so 200 divided by 24,000 cm cube, and this gives you 0.00833 moles. And remember to round off your answers in 3SF. Okay, with that, we have come to the end of this section on molar volume and molar volume of gases. Hope that you are more comfortable and you are versatile in using this formula to calculate either the volume of gases or to calculate the amount of gases in moles. Okay, so we can stop the video and go and do the next section.